when people hear from people like me who repeat this over and over again that the standard model has been confirmed to something like 14 decimal points, it's our and as you've said, it's our best empirically confirmed theory. What exactly does this mean?
Well, you can't quite say, I would like to be able to say, but you can't quite, that the standard model is confirmed to like 14 decimal places. Parts of it are. In fact, mostly the parts that are electromagnetism. That's the one that we understand the best. But the weak and strong nuclear forces are confirmed to a few decimal places, but maybe not, to 14. What it means is, for the most part, and this is not the whole story, but this is the most important part of the story, we scatter particles off of each other. We collide particles together and we see what comes out. This is the paradigmatic thing that you're taught to do when you take your quantum field theory class. You imagine setting up an initial configuration where two particles are coming in to hit each other. They hit, they convert, because they're really waves in a field, and those waves are going to set up vibrations in other waves, so they go out as other kinds of particles. And there's a mathematical description for what happens using Feynman diagrams. And Feynman diagrams are this beautiful way of calculating the probability. Given some initial state coming in, what is the probability of observing different states going out? So either metaphorically or literally, that's what we do. At a place like the Large Hadron Collider in Geneva, we literally do that. We collide particles together, we predict what's going to happen using Feynman diagrams, we see what comes out, and we compare that to the predictions. That's where we get to say the standard model is so enormously successful.